This topic is about the transfer function. And so most likely we will learn what we have, or we will use what we have learned from Laplace transformation into a useful thing for signals and systems course. So let me just start about today's lecture, which is Monday, and the readings are from page 106 to 108, which is related to the transfer function. And it's the due date for homework number 8, so you should submit this. If not, please reach to me. I can maybe extend it for you for 4 p.m. today as an exception, because I assume you had a spring break, maybe a different time. And in Wednesday, 13, so it is, the read is from page 131 to 134, and there is another homework number 9. Okay? Friday, the readings are from page 134 to 140, and of course the two important tables related to Laplace transformation and the properties, which is table 3.1 and 3.2 in page, I think, 96 to 97, something like that. We will use them a lot, and I'm not going to assume that you will memorize this. So this table, it will be even provided to you in the test, but you need to know how to use these tools. Okay, that's the most important, which is how to use these tables. Okay, now let's start a new topic. We already know how to do the transformation with different properties. Sinusoidal, how to do Laplace transformation from time domain to S domain or frequency domain, and the vice versa from frequency domain to S domain. Basically, you can use the table. You need to know how to use the properties. Sorry for that. Then, which is how to convert to time, from time to phasor, and the vice versa, from S domain or frequency domain to time domain. I'm going to write the transfer function. Okay. Now, we will use what we have learned from Laplace domain into our system. So our problem in signal system that we stopped last lecture, or we stopped after at the end of the first exam, in the convolution, right? We used to say that we have a system here, x of t, then here we have h of t, then y of t. Basically, y of t is the convolution of x of t convolved with h of t. That's what we have learned before, and we used to say, let's apply the convolution properties, or let's do the graphical way of convolution, and basically, it's based on integration. Okay, that's what we learned before. Now, let's use, based on this, using Laplace transformation. So actually, again, our condition or our target is we will assume we have a causal system. Causal system means that x of t and h of t are causal, of course. H of t, and even like y of t, all of them are causal systems. So this is part of LTI system, linear time invariant as well. Causal and linear time invariant. Now the good thing about this, or using Laplace transformation, x of t, that's the Laplace transformation for every part. X of t will be x of s. Keep in mind x of t was lowercase, now it will be x of s as uppercase, x as uppercase. Now h of t will be h of s. All of them are frequency domain. Then y of t will be y of s, uppercases. Okay? We used to say in time domain h of t as the impulse response, right? Now, h of s, here is the thing, it will be called a transfer function, which is the Laplace transformation of h of t. So h of s is actually the Laplace transformation of h of t, which is the impulse response, right? So the Laplace transformation of impulse response will be called as the transfer function. So h of s is the transfer function. And it is LTI system. An LTI system. And of course, LTI system, of course. So, again, whenever we talk about the h of t now as an impulse response or like as convolution, we'll say again h of t, h of s is in frequency domain as transfer function. Now the thing which is how to compute the transfer function. Then how can we use this in real life? The good thing about the transfer function here, we used to say y of t equal x of t times h of t. That's what we used to say in sandwich. The good thing about the transfer function, or like when we convert this into Laplace transformation, h of or x y of s will be x of s times h of s. The convolution will be converted to be a product. It will no longer be convolution. You don't need to do the integration. You don't need to do anything. So we can say that if you need to calculate any response or any output, you can use the graphical way, you can use the properties, or we have a third way that we can use a Laplace transformation, and that's what we are using actually in real life. Because when we have more complicated signals, I mean, before when we studied the first exam, we did a small graph, small inputs, and it was too complicated for us, right? It was not fun. But here, when we have any signal, convert this to Laplace transformation, do the products, then do Laplace inverse. That's it. Then I don't need to do the conversion. I have x of t, convert it to x of s. I have h of t, convert it to h of s. Find Laplace, make the products, then do Laplace inverse. I can find y of t. No matter what's x of t, if I know how to do the Laplace transformation, that's fine. The other thing, which is how to find Laplace inverse, by using partial differential equation, also partial fraction expansion. So how to compute, how to find the transfer function. So the transfer function, again, it is the Laplace transformation of h of t. That's one way. Other ways, if I know the inputs and I know the outputs, but I don't know what's inside the box, which is transfer function. So the transfer function can be also the relation of the outputs over the inputs. So it can be h of s equals to outputs over inputs in frequency domain, which is, in other words, output is y of s, inputs x of s. So if you don't know what's h of t, then you can find h of s by saying y of s over x of s. If you know h of t, then you can do Laplace transformation for s. So depending on what tools that you use. Okay? Now let's do more examples to see how can this be beneficial for us, how can this be helpful. Here is an example. So we need to find the impulse response of this system. Assume we have that LTI system here, then we have u of t, the output is y of t, okay? So the outputs is, or let's here we find, we find it. So the outputs y of t equals to be 2 plus 12 e power negative 3t minus 6 cosine 2t, all of it times u of t. This is what. So by looking at this system, you will see that, okay, the input is u of t, the output is y of t. The question says find the impulse response. Impulse response means h of t, right? How to find h of t based on the system that we have? Look at the system, the input is u, right? This means y, this is ya, what's called y what? Is this one impulse response, step response, Rabi response? What do you think this one will be? We have input is u or step, the output is y of t, like this expression. Now, what's the name of this? This one. Is it step response, impulse response, or ramp? Step response. Why? Because the input is step, right? So we will say that we already know the y step. We already know y step, right? So our target is to find h of t. H of t. What's the relationship between h and y? Between step response and impulse response. Do you know? Do you remember? H of t equal to what? Is it integration or derivative? Derivative or integration? Derivative. So you can find this by doing the formula. That's one way, using what we learned from example, from first example, using the properties. Now there's another way, step number or method number 2. You can, method number 1 you can find by yourself. Method number 2, let's use Laplace transformation. Using Laplace transformation. So basically, we have that u of t, which is the input, x of t. So the input, x of t, in other words, u of t, convert this to Laplace transformation, which will be x of s. So the step inputs, u of t, according to the table, it will be 1 over s. Okay? Now the outputs, u of t, equals to what? We have it as 2 plus 12 equal negative 3t minus 6 cosine 2t, all of it multiplied by u of t. So 2 times u of t, this will be 2 over s. 12 equal negative 3, it will be 12 over s plus 3. Then here cosine 2t will be negative 6s over s squared plus 4. So as a result, we will say that y of s will be 2 over s plus 12 over s plus 3 minus 6s over s squared plus 4. Okay? Again, how I find this, you can go back to the tables and see how you find the exponential, how you can find the exponential 2 times u of t, how you can find the cosine. Okay? Now, I need to find the impulse response, or the impulse response, as we know, is the Laplace inverse of the h of t is the Laplace inverse of the transfer function. So let's find the transfer function first, then we will do the impulse response. Transfer function h of s is output over input in frequency domain. So it's going to be as y of s over x of s. So y of s is given as 2 over s plus 12 over s plus 3 minus 6s over s squared plus 4. All of it divided by 1 over s, means multiplied by s of the sides, So this yields h of s will be 2 plus 12s over s plus 3 minus 6s squared over s squared plus 4. Okay? This is the transfer function. Again, the question didn't ask on the transfer function, it asked to find the what's called h of t, or the impulse response. What's the relationship between the transfer function and the impulse response? What do you think? What are your thoughts? I want to hear from you. How to find h of t, or how to find the impulse response? What's the relationship between the transfer function and the impulse response? What's the relationship? Transfer function in S domain, right? Frequency response in what's called the impulse response is in time domain. Okay, so I'm gonna write it here. So please, you need to be aware of this. Time domain, S domain. In time domain, this is called impulse response, which is h of t, and S domain is called transfer function. Which is h of s. How to find h of s? It can be either outputs over inputs, y of s over x of s, or it can be Laplace transformation of h of s. Okay? This is crucial. It's very important for you to understand. What's the transfer function? Again, what's the transfer function? It is the Laplace transformation of impulse response. Okay? Now, again, are you aware what impulse response is? Recall, by the way. The impulse response means what's the outputs when the input is dealt with. Just a quick recall. Let's go back here. If we assume x of t is delta, and we have this system, we want to see the output. This output is called impulse response, when the input is only delta. Now, what's the relationship between impulse response and transfer function? That impulse response, when the input is delta, can be converted to transfer function, or can be converted to S domain. That S domain is called transfer function. Okay? Does this make sense? Now, we have h of s as the transfer function. We need to find the impulse response, since the transfer function and the impulse response are just Laplace transformation. So let's do Laplace inverse, right? In order to find h of t, it will be Laplace inverse of h of s. Now, how to find the Laplace inverse of h of s? Okay, recall, I'm going to write here h of s is 2 plus 12 s over s plus 3 minus 6s squared over s squared plus 4. Now, by looking at this, how can we solve it? We can solve it one way, by doing the partial fraction expansion, PFE. And let's apply the partial fraction expansion. We will see that we need to make sure everything is strictly proper. Strictly proper, the order of denominator and numerator. Let's make sure that the denominator has higher order than numerator. So we need to make sure the order, is it higher? Is it strictly proper? Let's look at 12s over s plus 3 and look at 6s squared plus s squared plus 4. Now, look at, again, term A, look at term A. At term A, the first term A, is it strictly proper? No. The order of the denominator and numerator are equal to each other. because we have operator S here, we have operator S here. How about term B? Is it strictly proper? No, it's not proper because we have S squared, we have S squared. What should I do? Long division. Okay? So you see here, this example is cumulative. We are using many things. So let's do the long division first with 12S over S plus 3. Now, 12S, start with the higher order, 12S divided by S, 12. Then do the multiplication. 12 times S, 12S, 12 times 3, 36, right? So plus 36. Now let's do the subtraction. Do the subtraction. So 12S and 12S will cancel each other. 36 will be negative 36. So the answer for that will be as for the term A, which is 12S over S squared S plus 3, will be as 12 plus negative 36 over S plus 3. Okay? Because we have here the quotient and the numerator. This is the quotient, here is the numerator. This is quotient, this is the numerator. Okay. Now we are done with the first one, with term A. Let's do with term B. Term B. What do we have in term B? Which is, let me write it here. Negative 6. I'm going to write it as 6S squared without the numerator. So 6S squared divided by S squared plus 4. We need to do the long division. So it's going to be 6S squared divided by S squared plus 4. Let's start with the higher order. 6S squared over S squared will be 6. 6 times S squared will be 6S squared. 6 times 4, 24. Then do the subtraction. So when we do the subtraction, this will cancel each other. 24 will be negative 24. So as a result, this term can be written as 6 plus negative 24 over S squared plus 4. Okay? Does this make sense? Now, I'm ready to substitute them on the overall function, which is again, h of S after doing this partial fraction expansion, it will be as 12, 2, then plus term A, plus term B. So it will be 2. Term A is actually 12 plus, so it will be minus 36 over S plus 3 plus term B. Term B actually was minus term B because there was a negative sign. Again, here there's a negative sign. That's why it is negative. Minus term B, then put the brackets. This is term A, this is term B. Term B, I'm going to substitute it. It will be 6 minus 24 over S squared plus 4. Now, it's, before doing anything, make sure to distribute the sign. So this will be as 2 plus 12 minus 36 over S plus 3 minus 6 plus 24 over S squared plus 4. Okay? Do you agree with me? Just make sure it's a math. Then 2 plus 12, 14 minus 6 will make it 8. So 8 minus 36 over S plus 3 plus 24 over S squared plus 4. Okay? Now I'm ready to do what? Laplace inverse. So here is h of S. Now to find h of t, h of t will be Laplace inverse of, I'm going to make each term alone, 8, then minus Laplace inverse of I'm going to put 36 here alone, 1 over S plus 3, then plus 24 Laplace inverse of 1 over S squared plus 4. Okay? Now let's do Laplace inverse for everyone, for every element. What's the Laplace inverse of a constant 8 as a constant? It's impulse. So it will be 8 delta of t, right? Then minus 36. What's the Laplace inverse of 1 over s plus 3? Go to the table. Let me go to the table. Let's see. Laplace inverse 1 over s plus 8. E power negative 8t u of t, which will make it e power negative 3t u of t. That's what I'm going to substitute. So e power negative 3t u of t. Okay? Then plus 24. What's the Laplace inverse of 1 over s squared plus 4?
Sine 3t.
Okay, that's good. So it will be, looks like sine 2t. So let's go to the table and see. 1 over s squared so we see here there's a sign, right? There's something that we need to worry about. Here is omega, here is omega. So if I will say sine 2t, it needs to be like this. So here. So we know from that table, omega naught over s squared plus omega naught squared, then this will be as sine omega t u of t, right? Then in order to say, here we have 4, s squared plus 4, so it will be as 1 over s squared plus 4 is actually 2 squared, then it will be as sine 2t u of t. But we have another thing, which is this one must be 2. That's how we can make it sine 2t. Again, I'm going to rewrite it to make sure that you understand this. So the initial thoughts with this expression, 4 squared is actually 2 squared will be 4, right? Then the initial expression or the initial guess, we will say it's sine 2t u of t. But let's think about sine 2t. Sine 2t is actually 2 over s squared plus 2 squared. Or in other words, it will be 2 over s squared plus 4, right? Look at our expression, it's 1 over s squared plus 4. So what should I do if we have 1 over s squared plus 4? I'm going to multiply by 2 over 2. Then this will be as 2 over s squared plus 4 all of it times 1 half. Okay? So you need to see this trick, because you're definitely going to see something like that in the homeworks, exams, etc. Then, now I'm ready to do the inverse. It will be on cosine or sine 2t u. That's how we figure it out. So then it will be like this. So what I'm going to substitute, which is going to put it here, then plus 1 half sine 2t u of t. Then we can simplify it more by saying 1 half times 24 will be 12. Then the overall we can say h of t will be 8 delta t minus 36 equal negative 3t u of t plus 24 plus 12 sine 2t u of t. Okay? Now, that's the end. This is the final answer. And probably we'll solve. This is using the other step, which is step number 2, using the transfer function formulas. Now, any question about this? Yes.
So, if we just take the time derivative of y of t, that would give us the same answer.
Exactly. So
the 2 u of t becomes a impulse of t. What does the bracket from that?
Yeah, what's the point of where 8 comes from, right? So let's try to find the derivative and see. Okay. y of t as a step equals to 2 plus 12 equal, I'm going to write it in a different page, so y step of t equal 2 plus 12 equal negative 3t minus 6 cosine 2t u of t. Then when we do the derivative, if we say like h of t equal d y step of t over dt. So it's going to be as 2 u of t, the derivative of u of t is what? 2 delta, right? Then plus 12 e power negative times negative 3 equal negative 3t. Then minus 6 cosine 2t, so it will be 6. The derivative of cosine is negative sine, right? Negative 2 sine 2t. Right, let's see. It will be as 2 delta of t. 12 minus times negative 3 will be negative 36. Negative 36 equal negative 3t. Negative 6 and negative 2 will make it plus 12 sine 2t, and all of them must become 2 of t times 2 of t. Okay, now I get it. That's the first thing. Now the other thing, which is we still have words, when we do this, the question says, how can I get the x? Right? Here we have 2. Our target or our answer was 8 delta t minus 36 equal negative 3t u of t plus 12 sine 2t u of t equals u of t. Now, that's our answer. Transfer function answer, right? And that's the step answer, right? The interesting question, which is, which one's correct? We have delta 8 and we have delta 2. What are your thoughts? Can anybody figure out? Yes.
Will you do the product rule for the exponential and the step function?
Yes, so the product of the product.
The product rule.
So can you say that again? Explain it.
So the negative 36 e to negative 3t u of t minus plus, yeah, so negative 36 e to negative 3t u of t plus 12 e to the negative t impulse of t?
Yes, that's okay. That's perfect. That's it. Now I think you got it. Perfect. Excellent. So the thing here, when I did the derivative, this is wrong. Why? Because you know the derivative of the products, okay? The derivative of the product is different. How? I'm gonna redo the derivative again. Here, y step is given as 2 plus 12 equal negative 3t times u of t, right? Minus 6 cosine 2t times u of t. Now I'm ready to do that derivative. Here I forgot u of t. 2 u of t. Now I'm ready to do the derivative. Let's do the derivative. dy step by d, which is this one will be h of t. Now the derivative of 2u of t, 2 delta of t, right? It's 2 delta. Now the derivative of 12 e power negative 3t u of t. Let's do the derivative of the exponential first, then the other one derivative of u of t. You know the derivative, which is when we have f times g derivative, it will be f bar g plus f g bar. You know this. That's the point that we missed for, therefore, that's why like your colleague asked where the 8 comes from. And now I think we can figure it out because the original assumption, the derivative were wrong. So it will be 12 e power negative 3t. The derivative of u of t is delta of t. Plus, now the derivative of the exponential is negative 3, so it's plus 12 times negative 3 e power negative 3t u of t. Okay? Do you agree with me? Let's do with the other exponential, the other term, which is here, negative, the derivative of the first part, 6 cosine 2t u of t. Let's do the u of t first. It will be 6 cosine 2t. Delta of t, u of t will be delta of t, right? Then, plus the derivative of the other part, which is 6 times cosine will be negative sine, negative 2, sine 2t u of t. Okay? Now let's do more simplification. So it will be as 2 delta of t plus 12 e power negative 3t delta of t plus 12 e power 12 times negative 3 will be negative 36. Negative 36 e power negative 3t u of t minus 6 cosine 2t delta of t, then plus here negative 6 times 2, negative 6 times negative 2 times 6, negative 12, then if there is a negative, it will be negative positive, plus 12 sine 2t u of t. Okay? Now, is it really the same as the answer that we did before? Our answer before h of t was 8 delta of t minus 36 e power negative 3t u of t, then plus 12 sine 2t u of t. Is it the same? Doesn't look like the same, right? What's the challenge? Now here, this is an interesting thing because I want you to think about it. This is not the same, right? 12 sine, let's see, 12 sine, they are already here. Okay, there is no problem. Exponential, this exponential, that's good. The challenge is here in delta. We have this delta, we have this delta, this delta, this delta. How can this be 8? What do you think? Any thoughts? Oh, I want you to think more about what we learned from the course. In other words, how can we say 2 delta of t plus 12 equal negative 3t delta of t minus 6 cosine 2t delta of t? Is this really equal to 8 delta of t? The answer is yes, but how? Yes.
17 is enough.
Exactly. Recall from the step function properties, f of x or f of t involve multiplied by delta of t. This is equal to f of 0. When you have f of t times delta t minus t0, this will be f of t0. And that's what's happening here. So this yields to be 2 delta of t, and then for the delta of t. This even though it would be f of 0 times delta of t, here times delta of t minus t. This is one of the properties of the delta function. So it will be 2 delta of t plus 12 plus 12 substitutes t equals 0. Negative 3 times 0, delta of t, minus 6 cosine of 2 times 0, which is cosine of 0, delta of t. So e power 0 will be what? 1. So 2 delta of t plus 1 will make it 12 delta of t. Then cosine of 0 is what? 1. minus 6 cosine of 0 delta, minus 6 delta of t for this one. Now, 2 plus 12, 14, minus 6, 8. And we get it. So that explains how we get this. So that trick here, the first thing, when we did our analysis, or I did it purpose, which is, we didn't do the derivative corrects. So make sure it's a product. It's not a derivative only of exponential alone, or it's the derivative of the sign alone. The other thing, which is when you do the delta of t times any function, if it's delta of t alone, substitute t equal to 0. If it's delta t minus 1 minus 2, t minus t0, or t minus tau, substitute t with this value, tau at 1. Again, we know this before, but now we just like have some practical challenges, or some challenges, more challenges for it. So anyway, the overall results, again, what we get to find the impulse response is 8 delta of t minus 36 e power negative 3t u of t plus 12 sine 2t u of t. Then problem done. So again, this can be done in two ways. The first way, using the properties that we learned before. The second way, using the Laplace inverse. The Laplace inverse by finding the transfer function. Now, I'm going to go to another problem. I'm going to start. I don't think I will be finishing today, but I'm going to start. So, problem, I think in the textbook 324a. So we have a system that the transfer function of that system, h of s equal to 18s plus 10 over s squared plus 6s plus 5. That's the transfer function. Now, the question says, if the input is, which is x of t equal to u of t, find y of t. So basically, we need to do the Laplace transformation to do this problem. You can imagine this problem as we have here h of s or h of t, then we have here x of t, then it will be y of t. The best thing to deal with this, let's find this, since we already know h of s, then we can find x of s to find y of s. Let's find y of s first. After calculating y of s, we can do Laplace inverse. So we have x of t given as 1, x of t given as u of t. Therefore, x of s equal to 1 over s. h of s is already been given. How to find the output, since we know h of s and y of s? What's the relationship between the transfer function and the output? We know h of s equal to what? Output over input, right? Y of s over x of s. Or in other words, we have it as given 18s plus 10 over s squared plus 6s plus 5. Is this correct? Again, the definition of the transfer function, output over input. Now, I need to calculate y of s. Y of s is actually h of s times x of s. So it's going to be h of s 18s plus 10 over s squared plus 6s plus 5 times 1 over s. In other words, it will be y of s will be 18s plus 10 over s cubic plus 6s squared plus 5s. How to find y of t? Y of t is the Laplace inverse of y of s. How to find y of s? Or I mean, how to find y of s, or to convert y of t to make Laplace inverse? By doing the partial fraction expansion, right? How to find the partial fraction expansion? The question is this function strictly proper? Yes or no? Look at the highest order. The highest order is s. The highest order is s cubed. So it's strictly proper, right? Then we can do partial fraction expansion. So how can we do to do the partial fraction expansion? look at the roots. S cubic plus 6s squared plus 5s equal to 0. Or in other words, we can say take s as a factor, will be s squared plus 6s plus 5 equal to 0. This means it can be as s plus 1, s plus 5, or you can use the formula, which is the general formula to find this, the product of the group. We'll make it 0. So as a result, we can say 18s plus 10 over s cubic plus 6s squared plus, or I would say I can write it with the roots, over s times s plus 1 times s plus 5 equal to c1 over s plus c2 over s plus 1 plus c3 over s plus 5. Then we need to find c's, then we need to do Laplace inverse. Basically, we can say c1 will be y of s times s, and substitute when s equal to 0. c2 will be y of s times s plus 1, substitute when s equal to negative 1. c3 will be y of s times s plus 5, substitute when s equal to negative 5. This yields to these answers will be 2, 2, negative 4. So you can substitute this at home, so it will be 2 over s plus 2 over s plus 1 plus negative 4 over s plus 5. Now I'm ready to do Laplace inverse. So y of t will be Laplace inverse of y of s. Then it's going to be as 2 u of t plus 2 e to the negative t u of t minus 4 e to the negative 5t u of t, then probably done. Any question? Okay, so that's